Hey everyone! Last week, one of the things we discussed was how to merge two sorted arrays efficiently. Today, to finish off our recursion topic, we're going to level that up into a full sorting algorithm. We're going to talk about merge sort, which is a recursive sorting algorithm. By the end of the video, you're going to understand the idea, you'll be able to trace through it on a small example, as well as be able to implement it in Java. So the big idea today is going to be divide, conquer, and combine. We already did the combine last week. Let's get my normal main method up and running, as I always begin my videos with. Main.java. All right, let's do it. So we know that selection sort and insertion sort are very simple for us to implement and also to understand from last week, but they can be pretty slow on larger inputs. Merge sort will use this idea of divide and conquer to guarantee a faster running time. It also is what's known as a stable sort, which means that elements that are equal to each other keep their original order. And this can be very handy for some situations like multi-key sorting algorithms. Let's start with some pseudocode to get the main idea down. So sudo merge. I can spell sudo merge. Merge sort will probably take in some array. Just do it like that. It's just some pseudocode. So the first thing we're going to do is we're going to make sure that the length of our array has at least 2 elements. It needs to be at least as big as 2 elements, strictly greater than 1. And as long as that's the case, let's keep going here. We're going to split it into the left and the right half, just like the walkthrough with those cute little monsters that I did in the previous week. Split into a left array, and right array. After we've split them both up, we need to call our merge sort algorithm on each of those halves. So we're going to call our sudo merge on our left half, and we're going to call our sudo merge on our right half. Once we've done that, and we've broken down our problem all the way to its smallest size, we're going to merge our two halves back together. We're going to take a merge, we're going to take our original array, and a right array, our left array, and our right array. We're going to merge them all back. And this is the one that we already know how to do, that we covered last week. And this is all there is to it. Notice I don't actually have a base case anywhere, because my base case is if I have 0 elements or 1 element, do nothing. And that's because an array of size 0 or size 1 would already be sorted. Now, rather than draw this out, we're going to just trace through an example with a visualizer that I have online here. This is a merge sort visualization tool. We're going to go ahead and predefine some values that we want to run over. 6, 1, 2. And let's run. So what we can see is there's going to be a lot of steps to do this whole array, and that's okay. Here's our array in the order that I specified. This is going to bring us all the way back to the beginning. This is going to take us all the way to the end where it's sorted. And of course, we can take steps in between. This is very similar to how Python Tutor works. So let's start by realizing what we're actually going to do is take the array and split it into halves. We have a left and a right, so we calculate a midpoint. Our left array goes from 0 to the middle, and our right array will go from the middle plus 1 to the end of the array. We then call merge sort again on the left side. So our left subarray gets called merge sort with another split. So our merge happens again, or our merge sort pseudo merge at this point happens again, where we split it in half and break up these two pieces. We still haven't gotten past calling the left subarray recursive merge yet, because what will happen is after we've done that split, we once again call the merge sort on our left subarray. At this point, we've now hit our base case being arrays of size 0 or size 1. We can see that this one cannot be split any further and it's ready for merge, and that's also true of the left side. After we have called the merge on the left and the merge on the right, a quick reminder after we call those two left and right, we get to do our merge back together. And so these two elements are now going to get merged back together using that merging algorithm that we saw last week in the correct order. Ta-da! And now they're going to be swapped. This actually does happen all the way up here at this level too. We are always working in memory in the same array, like in place. It's just not propagated up yet. But in theory, it is absolutely happening in place. So these two elements up here would have also been swapped. Once we finish on that side, we've finished the merge, and our algorithm can pick back up where it left off. It just finished calling the split and merge from the left. Come back here. Well, after that, what comes next is the call to pseudo merge on the right. So we're now going to select the right subarray and do the exact same thing, which also includes hitting our base case and merging them back together. Well, after we've done that, we've now completed this level's left and right subarray merges. Left and right. What happens next is the merge of the left and right subarrays. And you will notice that once again, we have two ordered subarrays that we're now going to combine back together. We do so with the algorithm that we looked at last week. Just click through this kind of quickly because we did look at it last week already. And we now have a fully sorted left side, of our array. What do we do once we're finished with our left side being sorted? No problem. We're going to do the exact same thing down the right side. Now I'm just going to click through this so that we can just reach the very end, because we already saw this happen on the other side, where we kept saying left, right together, left, right together, left, right together, and so on and so forth, until we reached the point where we propagated all the way back up to our initial size 4 subarray. We now have our two completely merged, or rather sorted, subarrays that now need to be merged together. And once again, we're just going to call the merge selected arrays back together in sorted order. Each of those happen using that merge sorted arrays method that we looked at previously. And at the end of all this, boop, we'll end up with done sorting, everything being in the right order. It's pretty magical, and the code is pretty straightforward. We're going to look at the code next. So the very first thing that we're going to need in order to get this code up and running, I suppose besides a main, let me just close that off and put in a main. We're going to need that helper merging of two sorted arrays method that we looked at last week. And I have no intention of going through that code again. I'm just going to sort of pop it in here with my movie magic. And then if you do want to go back through it, you can go watch the previous video. And then I will show off the code for the actual splitting of the two arrays and the recursive call that comes with them. So that's going to be basically this code right here. The merge we already previously did. For ease, we are going to return the sorted array rather than make all those changes in place, just to make it a little bit more explicit. But with a few small tweaks, this algorithm can actually be done completely in place without the need for a temp array. It does sort of complicate the algorithm a little bit though, so we are going to use a temp array for right now. All right, let's walk through the code that I've added to my file here. There isn't a lot of variability when it comes to writing a merge algorithm, so I didn't see a ton of value in sitting here and writing it in front of you. Feel free to pause the video and go through my code a little bit more detailed if you want to, but I will sort of trace through it and talk through it right now. So I started with making an integer array in my main, and I will print it out just so we can see what it looks like unsorted. I will then call my merge function, get an array out of it, and then I will print it all out after to ensure that it is now sorted. Just going to make sure everything prints out on their own line. Okay. Now I do have the merge sorted arrays code from before. I'm not going through that again, but let's take a quick look right here at my merge. So it looks exactly the same as my pseudocode. If my length is greater than 1, we're going to find the midpoint, make two arrays of the correct size. These just move every single element over into the left and right arrays. Copy into left, right arrays. could use system.array copy if you want. That's always an option. And then we go ahead and begin the conquer part of the divide and then conquer algorithm. We're going to merge the left side and call merge on the right side. These are our merge algorithm. In fact, I think this should probably be named merge sort. I don't love the name of it. Makes it confusing. Once all those things have happened, we're going to combine our sorted arrays and we're going to return them. Now, all of this is this is not my base case. All of this is my recursive case, right? If the array length is greater than 1, we want to do all this. What do we want to do if it's not greater than 1? Then that means it's 1 or 0. We just want to return the array itself. We could have made a temp variable here instead of multiple returns, and both would have been acceptable. Let's go ahead and run through this code and see what the heck is going on. Make sure that it works. Oh. Let's compile. Oh, did I change the name of it by accident? Oh, whoops, yeah, I copied this. This should have been data. There we go. Okay, let me try that one more time. Compile. And run it. And we can see it did actually sort our array. Let's break this down just one step further, and let's do this print. I guess at the top of each of these calls. So instead of doing the print here, and instead of doing a print here, no, I can leave that one. We are going to print right here and say top of merge sort. And it's going to just print out everything in the array at each step, just to see what's happening every single time merge sort gets called. The very first time merge sort gets called, it should just give us this whole array. Let's go ahead and check that out. All right, it's exactly what we expect. So first off, we get the whole array, then we get our left subarray, then we get our left subarray, then we get our left subarray. Once the left subarray has hit a base case, we go and do the right subarray. Once the right subarray has finished its base case, we go back up a level and we end up right here. So we get the right subarray. We get the left subarray of the right subarray and hit a base case. We get the right subarray of the right subarray. So we hit a base case. And once we've propagated that all the way through, this whole side has finished processing, and then the other side can begin to process all the way down until it all comes back together. By adding a few more print statements, we actually would be able to see more. We'd be able to sort of visualize what our visualizer showed us if we wanted to. But I will leave that up to you to go through if you want to. Now, there are a few common pitfalls that we want to make sure that we're being aware of when we're running through our code. The first is any off by one sort of index calculations. It's pretty easy to make a mistake and end up with mid, left, or right, sort of plus or minusing one somewhere that causes a problem. It's also very common for us to forget having some kind of a base case. We often will put our return inside of that if statement, and we're going to get errors and not be totally sure why. We need to have returns out of every single branch, including the branch where we don't go into our if at all. Now, if we allocate a new temporary array inside of our recursive calls, instead of doing it inside of the merge sorted arrays call, we can find ourselves just moving a little bit slower. Like our code might take a little bit longer, but it's still going to be significantly faster than if it was doing an insertion sort or a merge sort. And yeah, the most common mistake is most definitely the mixing up of those subranges where we end at mid, or if we start at mid plus 1, or however, those two indices overlap. So what we see here is that merge sort is basically broken down into 3 steps. We divide our array, we recursively call our sort on each side, and then we merge them back together. It's stable and deterministic, so it always works. It always comes out with the same answer given the same input. And it's really easy to do with recursion. This is what finishes off our recursive topic this week. And next week, we're going to start discussing multidimensional arrays. Thanks, everyone, and see you there.